Hey, this is Dr. B, and let's take a look at Heisenberg's uncertainty proposal. In the early 20th century and prior to that, the atom was considered to be matter and matter only. It's a thing, right? And as such, it would behave with normal properties that you would assume with matter. For instance, it wouldn't be expected to be in two places at the same time. However, after the work of Niels Bohr, as the 20th century rolled on, people started to realize that the electron is so small that it behaves a little bit more like light or energy than it does like matter, or it's a mixture thereof. They call this the particle-wave duality. And perhaps it's not so surprising that as something gets tiny, it behaves a little bit like matter and a little bit more like energy, something that has no mass, takes up no space. And that's what the electron is believed to be. Heisenberg was one of the first people to clue in on that. What he said in so many words is that electrons are not quite a thing. They're part matter and part light. As such, it's not appropriate to say where they are because they're not quite a thing. They're in between. Isn't that fascinating? So let's talk about it in terms of probability. That'll at least give the people that deal with think of an electron as a particle of matter, like chemists tend to, and make them happy, right? That'll at least be somewhat true, right? There's a probability there. The physicist, who oftentimes took a outlook for the electron based on it being more like light, don't need such limitations. They think of it in terms of energy sometimes first and foremost, and that's a different way of considering the electron. Both have some truth to them. Einstein, not surprisingly, being from an older school, had trouble believing this, and he made the famous comment at first that God does not play dice with the cosmos. Dice in terms of talking about them in terms of probabilities or odds, and he initially thought that Heisenberg was wrong. This concept of electrons being part matter, part light is at the heart of our understanding of the atom and therefore the universe at this point, and it behaves well with experiment. And so the Heisenberg uncertainty proposal is really closer to the fundamental truth as we understand it at this point in time.